Am I audible? Am I
Yes, sir.
audible? Yeah, okay, perfect. So shall I share my screen? I mean,
Yes,
okay.
sir.
Okay. Perfect. So, good evening, everyone. This side Dr. Abhijeet, and welcome to yet another session of carbohydrate biochemistry, like part two, in which we are going to discuss some important questions, some important past previous year questions, right? In today's session related to carbohydrates biochemistry. So guys, this series has been initiated from July 1st, and no, we are covering the most important, most volatile topics that no are the potent questions for the upcoming university exams in August. So we are revising each topic in a very crisp, concise, and conceptual manner. And even the students who are going to appear for NEET PG, they can also avail the benefit from this particular live session. So yeah, so these are the questions that I will be discussing up today. I will be discussing a long question regarding to related to the mucopolysaccharides, right? Apart from these, all these three questions I will be covering up today, and even some short questions like the Benedict's text, the muta rotation. Yes, we have talked a little bit about it. So yes, I'll be like dealing it with today, and heteropolysaccharides and yeah, some heteropolysaccharides we'll be discussing today, right? So these are the core features of the Oracle app. Like we are having these live classes which are now streamed on YouTube also. If even if you miss, you can go to the recorded classes that are being available on the app. Apart from that, you have the hard copy notes, right, which are curated in the form of Q&A, the question and answer format that is very, relevant to the university exams, right? Apart from that, after each and every topic, guys, we have this MCQ session, right, in which we have basic to advanced level MCQ, and that is something you guys already know, like all the previous year topics and questions are being covered in this, right? So that is something you have to remember. Now, so we have the combo plan, guys, that you can see over here that is valid till July 15th. Okay, like we have, I hope the dates are being extended, guys. So yes, so we have the features of all the recorded classes, the live classes, right? And the hard copy notes. It's now this offer is again uh, going on. So you can just buy this combo plan right now. Yes. So this is the basic subscription plan. Like we have, even if you want some extra additional discounts, you can use my code Dr. Abhijeet 20 for some additional discounts, right? So let us start with the very first question that is we are discussing today. That's a previous year question. What are mucopolysaccharides? So let us first discuss what are these mucopolysaccharides. Now, mucopolysaccharides are nothing but, let us just try to answer the first question over here. Answer number one. Now, we already know it is mucopolysaccharides, right? Mucopolysaccharides. Now remember, guys, it is also called as glycosaminoglycans. Glycosaminoglycan, right? Now, this glycosaminoglycan, it is basically a heteropolysaccharide. It is basically a heteropolysaccharide. We have discussed this yesterday also. It is a heteropolysaccharide. Now, guys, again, be very clear with the terminology, guys. Whether it is mucopolysaccharides, whether it is glycosaminoglycans, that is GAGs, or whether it is heteropolysaccharides, they are one of the same things, guys, right? So remember, right? Now, heteropolysaccharide, basically, you already know hetero means different, guys. Hetero means different. So over here, you already know the monomer unit. Okay, the monomer unit in glycosaminoglycans can vary, right? It can be different, right? So that's why it is called the heteropolysaccharide, right? Now, guys, remember what is this glycosaminoglycans? We are saying it as mucopolysaccharides. So remember that Glyco means glycogen, guys, and you already know glyco over here stands for carbohydrate, glycogen, right? The carbohydrate. We have amino, guys. We have amino. So remember, it is amino sugar. It is amino sugar, guys, right? Amino sugar. So remember, guys, glycosaminoglycans, if we just, I want to just like write in short, remember it is a long, unbranched, heteropolysaccharide, right? And it has a repeating disaccharide unit. Repeating disaccharide unit. It has a repeating disaccharide unit. Now, if I just want to show it schematically, guys, so we have like this is like unbranched, so it will be like this, guys, right? I'm just trying to draw it. Yeah, a repeating disaccharide unit. If you can just see over here, right? So that is the, yeah, over here you can just mention this is the disaccharide unit, right? And that is repeating. Disaccharide unit that is repeating. So why this muco, guys? Mucus, guys. It is first seen in mucin, guys. Mucin, right? First seen in mucin, right? So it is also called as mucopolysaccharides, or we commonly called as MPS. Mucopolysaccharides, glycosaminoglycans, or heteropolysaccharides. One of the same things, guys, over here. Now, I have told you it has the repeating disaccharide units. It has repeating disaccharide unit. Remember, guys, this disaccharide unit, it is made up of two components, guys. It is made up of two components, and yesterday also we have like discussed it. So let us just try to like simplify it, whatever we have discussed. It is made up of two components, guys. We have amino sugar means amine group combined with a sugar, and we have acidic sugar also, right? We have acidic sugar also, right? So amino sugar plus acidic sugar, right? It is made up of two components, amino sugar plus acidic sugar, and it is repeated n times, right? Now, amino sugar, guys, can be of two types over here, and that is something you have to remember. It can be either glucosamine, glucose combined with the amine, or it can be galactosamine. You already know galactose combined with amine. So amino sugar can be glucosamine and galactosamine. And acidic sugar, guys, remember acidic sugar can be glucuronic acid. And the other one that you can remember over here, we have iduronic acid. Iduronic acid. So that is in a nutshell about what are the mucopolysaccharides. So this is long, unbranched heteropolysaccharide. It is long, unbranched heteropolysaccharide made up of repeating disaccharide unit. It is having amino sugar and acidic sugar. Amino sugar, it is glucosamine or galactosamine. Acidic sugar, either it is having glucuronic acid or iduronic acid. So that is something you have to remember. So these are nothing but this mucopolysaccharides. Now this is something which is written in the same in the Auricle notes, right? So these are heteroglycans. They are made up of repeating units of sugar derivatives. I have already discussed amino sugar and uronic acid, right? That is the acidic sugar or the uronic acids. So they are called as mucopolysaccharides, right? So we have amino sugars and uronic acid or acidic sugars. Uronic acids are something relevant like acidic sugars, right? So you already know. Okay, let us just try to discuss some properties of this mucopolysaccharides also. Let us just try to discuss these properties that is like more relevant over here to discuss over here. So let us just discuss this properties of this glycosaminoglycans, right? Now, remember guys, the very first thing, they are negatively charged. Negatively charged. Now, when I say GAGs, or I can simply say mucopolysaccharides. Mucopolysaccharides. Okay. Now they are negatively charged, guys. They are negatively charged. You already know they are polyanions. They are polyanions. Now, anions that move to anode, that is, they are called as polyanions. Now, why they are negatively charged, guys? Remember, it is because of different sugar. Because it has different sugar. Okay, it is having because of different sugar, guys. Now you already know we have two types of sugar over here. We have two types of sugar over here. We have amino sugar and we have acidic sugar. Right? We have amino sugar and we have acidic sugar. Amino sugar, it is, remember guys, amino sugar is something which is positive. It is positive, but this amino sugar, it is attached with, it is attached with sulfate, guys, right? Even it is also attached with acetyl, also attached with acetyl, right? CH3COO minus. So guys, even though amino sugar is positive, even though it is positive, guys, one component is positive, but it is attached to two components which are negative. So we have minus and minus, so it becomes more negative, guys. It becomes more negative, guys. And acidic sugar, you already know COOH. So COO minus, obviously it is having a negative charge. So negative, so it is basically negative in nature. I mean, it is negatively charged, guys. Coming from the amino sugar, though it is positive, but it is attached with sulfate and the acetyl parts. That's why it is like more negative. And acidic sugar, you already know acid is, they are having this negative charge. The second most important property, guys, over here, the second most important property that you have to remember, they repel each other. They repel each other. Now, why I'm saying that? Because you already know they are called as mucopolysaccharides. So you should remember, guys, these mucus secretions, they are very slippery. The mucus secretions are slippery in nature. Now, when you take mucus on your fingers, right, and you just do like this, it is slippery. What does it indicates, guys? It is rich in glycosaminoglycans, right? It is repelling each other, so mucus secretions are slippery. Mucus secretions are slippery. Now, guys, because of the negative charge, okay, we have the third property that you have to remember. They absorb more water, right? They absorb water because of this negative charge. Because of the negative charge, guys. Because of the negative charge. So they absorb water because of this negative charge. And remember, guys, this water, it is abundant in the extracellular matrix. It is present more in the extracellular matrix. It is abundant in extracellular matrix, right? It is abundant in the extracellular matrix. Now, again, guys, one more important property that I wanted to discuss over here, guys. Now, what happens when it absorbs water, right? When it absorbs water, what will happen to it? It will swell. It will swell. Okay. Now, what will happen? So it is removed from. Okay. Now, when it is removed from glycosaminoglycans. Now, when this water is removed from glycosaminoglycans, what will happen, guys? It will revert back. It will revert back to its original position. Okay. This is what is something called as compressibility. Compressibility. Or we can call it as resilient nature. Resilient nature, right, of glycosaminoglycans, right? So this is something which is seen in synovial fluids, synovial fluids, even in the vitreous humor, even in the vitreous humor of the eye. So these sites, guys, the synovial fluids and the vitreous humor, guys, again, a very important viva question that can be asked. So these sites are highly resilient because of this property of GAG, because of resilient, because of this GAG, right? So that's what we have already written. These are highly resilient, right? So obviously they are absorbing water, guys. They are absorbing water. And because of this negative charge, they're absorbing the water. What is happening? It will swell. Later on, when the water is removed, again, it will revert back to its original position, right? So it's just like the rubber band, guys. If you try to stretch it, right? And after that, you remove your hands, it will again come back to its original position. That is something called as compressibility or resilient nature of glycosaminoglycans or mucopolysaccharides. Abundant sites where this property can be seen, that is the synovial fluids and the vitreous humor in the eyeball. Synovial fluids, at the knee joint, right, the elbow joint over here, right? So that is in short about the properties of this glycosaminoglycans. So we have already discussed it is more negative charge, it is slippery, so they are heteropolysaccharides. No, this we already know. They attract water molecules, so they produce viscous solutions, right? So that is something you should remember. Now, mucopolysaccharides, they again combine with proteins to form the mucoproteins, guys. So that is you have to remember. So that was regarding the mucopolysaccharides. So the mucopolysaccharides, the major ones you should remember. The major ones, guys, I'm just trying to make a list over here. Yes. The major GAGs, glycosaminoglycans or mucopolysaccharides or heteropolysaccharides. The very first one you should know, it is chondrotin sulfate. Chondrotin sulfate, right? We have keratin sulfate. Keratin sulfate. We have heparin sulfate. Heparin sulfate. We have dermatin sulfate. We again have heparin, guys. Heparin, right? And we have hyaluronic acid. Hyaluronic acid. So that is something you have to remember, the major GAGs and the mucopolysaccharides. So the very first question that they have asked us, that are what are mucopolysaccharides, we have again discussed it. These are glycosaminoglycans or heteropolysaccharides, right? Or heteroglycans, we have discussed the composition, how they are made up of, and the properties of these mucopolysaccharides, along with some important mucopolysaccharides, the name. Now, the second question, the part which says they name the mucopolysaccharides present in the glomerular basement membrane. Okay, and what is its significance, guys? Now, let us just try to answer this question over here. Let us just try to answer this question over here. Okay. Now, the answer over here, the second question. Okay, the first question, guys. Yeah, obviously. It is heparin sulfate. I'm not like talking about this over here. So let us just try to answer this. Name mucopolysaccharide present in glomerular basement membrane. It is nothing but the heparin sulfate. The answer over here that you have to remember, it is heparin sulfate, guys. Again, it is not heparin, it is heparin sulfate, guys. Heparin sulfate. Heparin sulfate. Now, let us just try to discuss this heparin sulfate over here. I'm not talking about heparin right now. I will be talking about the first part, that is the heparin sulfate. Now remember, guys, this heparin sulfate, it is present in the basement membrane. It is present in the basement membrane of renal. Renal means the kidney, and kidney has the nephrons has the cell, and which part of the nephron? It is the glomeruli. Renal glomeruli, right? So remember the basement membrane of renal glomeruli, what it has? Heparin sulfate is present. Heparin sulfate is present. Heparin sulfate is present. Now, again, guys, very important concept over here. The question also says, what is the significance, guys? The question, if you can just say, what is its significance? So let us just try to see the significance over here. Now, remember, guys, that the renal glomeruli is having negative charge. The renal glomeruli, it is having which charge? Negative charge, right? Negative charge. So this heparin sulfate, it is responsible for, again, very, very important significance, guys, over here. It is the significance, it is responsible for charge selectiveness. Charge selectiveness of renal glomeruli. Charge selectiveness of renal glomeruli. Now, how to understand this? What does this mean, sir? You should know, guys, that there is something called, okay, why albumin? If I just simply ask you, why albumin is not coming into the renal filtrate, is not coming into renal filtrate, guys. Why albumin it is not coming into renal filtrate? Now this is something which explains the heparin sulfate role. Now guys, remember albumin, it is having which charge? It is having negative charge, right? And yeah, the renal glomeruli, it is also having which charge? Negative charge, right? Albumin having negative charge, heparin sulfate, HS I'm writing, heparin sulfate, it is also having which charge? Negative charge. Now guys, remember, this negative charge and this negative charge will repel each other. Okay, so yeah, the heparin sulfate will repel the albumin, okay, because albumin is also having negative charge. That is why it is not coming into the renal filtrate, right? So that is one of the significance, guys, that is responsible for the charge selectiveness of renal glomeruli. Apart from that, sometimes the examiner will also ask one important viva question that you can remember, that it is also present in the synaptic. It is also present in the synaptic and other vesicles. Synaptic and other vesicles. It is also present in the synaptic and other vesicles, guys, right? So, okay, it is also present in synaptic and other vesicles. Even guys, you can also remember 2-3 more important points over here. It is seen in plasma membrane receptors. It is seen in plasma membrane receptor. These are some extra points that you can remember over here, right? And remember this heparin sulfate, it is composed of, yes, it is composed of glucosamine plus glucuronic acid. Plus glucuronic acid, right? Even one more enzyme, one more significance over here that you can remember, that lipoprotein lipase, the enzyme, it is anchored. Anchored means support. It is anchored by heparin sulfate. It is anchored by heparin sulfate. So that is again one important significance that you can remember. The lipoprotein lipase, that is also anchored by this heparin sulfate. So that was regarding the first question, first part, that is the name mucopolysaccharides present in the glomerular basement membrane, that is the heparin sulfate, and the significance we have already talked about. It is seen in plasma membrane receptors. It is responsible for the charge selectiveness of glomerular filtration, right? Or the renal glomeruli, right? Filtration. Apart from that, it is present in synaptic and other vesicles. It is the enzyme lipoprotein lipase is like supported, it's anchored by this particular glycosaminoglycan, that is the heparin sulfate. So that is again about this mucopolysaccharide. Now coming on to the second part, explain the biochemical importance of heparin, guys. Now it is not heparin sulfate, it is heparin. Heparin as an anticoagulant, as an anticoagulant. So we have already like taken this from the notes, guys, the heparin, right? So remember, guys, if we just talk about the composition of heparin, if we just talk about the composition over here, what heparin is made up of? Remember, guys, it is made up of glucosamine, right? The amino sugar, right? The glucosamine plus the acidic sugar, guys. You should remember over here, the acidic sugar is ioduronic acid. Very, very important. Again, an important question for the exam. So the second question, the second part, right? The heparin. It is the composition as glucosamine and ioduronic acid, right? Now remember, guys, it is an anticoagulant. It is an anticoagulant. Basically, it is widely used when taking blood into in vitro for clinical studies, guys, right? So it helps to prevent the intravascular. Now, when I say intra means inside the vessels, right? The vascular, the blood vessels coagulation, the blood inside the blood vessels, they don't coagulate, right? That is due to this heparin, guys. Now, what does this heparin do? It activates antithrombin 3, which in turn inactivates thrombin, right? Factor 10 and L9. So heparin is present in liver, lungs, spleen, and monocytes. Liver, lungs, spleen, and monocytes. Apart from that, one more important question, the viva question that can be asked with respect to heparin, guys, over here. Remember that this is the only intracellular glycosaminoglycans. Very, very important. It is only intracellular glycosaminoglycans, right? It is present inside mast cells. Again, very, very important question. It is present inside mast cells, right? Lungs, right? Lungs, etc. So it is present inside the mast cells like the lungs, right? So it is the only intracellular GAG. Again, a very important Viva 1 mark question. Only intracellular GAG, it is heparin. We have discussed heparin sulfate. We have discussed heparin, right? So we have discussed 2 questions over here. So yes, mucopolysaccharides done. Yeah, heparin sulfate done, heparin done. Now, the third one, which mucopolysaccharide maintains the transparency of cornea? So the answer over here, it is keratin sulfate, guys. It is keratin sulfate. It is keratin sulfate. So let us just learn something about this keratin sulfate also over here. So yes, we have this keratin sulfase. So remember, guys, the keratin sulfate. Now, it is found in cornea and tendons, right? So yes, it is the only GAG which does not contain any uronic acid. No acidic sugar is present. No acidic sugar is there. Again, an important question, guys. They will ask you GAG glycosaminoglycans with no uronic acid. That is, yes, that is keratin sulfate. Now, guys, remember, guys, the keratin sulfate is basically of 2 types, keratin sulfate 1, and we have keratin sulfate 2. Keratin sulfate 1 and keratin sulfate 2. Keratin sulfate 1, it is isolated from cornea. It is isolated from cornea. And keratin sulfate 2, it is isolated from this cartilage, right? It is present in the loose connective tissue. Present in loose connective tissue. Loose connective tissue. Remember, guys, what is the peculiarity of this keratin sulfate? The peculiarity of keratin sulfate, it is basically responsible for, the question says responsible for corneal transparency. Corneal transparency, that is something you have to remember. The glycosaminoglycans, which is responsible for corneal transparency, it is the keratin sulfate. That is the third part that we have discussed. Apart from that, again, guys, one important question, that is the composition. So it is only composed of N-acetyl glucosamine. N-acetyl glucosamine, right? Plus galactose. Remember, the composition is important, right? The composition is important. It is composed of N-acetyl glucosamine plus galactose. N-acetyl glucosamine plus galactose. Okay, so that is like you have to remember about this keratin sulfate, and that is something which is written in the notes as well. So that is about the first question that we have discussed, right? The mucopolysaccharides, the heteropolysaccharides, heteroglycans, glycosaminoglycans, one of the same things. Heparin sulfate done, heparin done, and the keratin sulfate, which is responsible for the transparency of the cornea. And two important questions, glycosaminoglycans with no uronic acid, it is keratin sulfate. Okay, and only intracellular this glycosaminoglycans, right? Yes. That is the heparin. That is the heparin, right? So along with that, I have discussed like important question. Now the next question that we are going to discuss, it is about the Benedict's test and its importance, guys. Right? The Benedict's test. Now, guys, you already know we have two types of sugar, right? Reducing sugar and non-reducing sugar, right? So again, let us just try to like summarize over here. Okay. Okay, I'll just write over here. We have two types of sugar, guys. We have the reducing sugar and we have non-reducing sugar. Now, guys, you already know when I say reducing sugar, when I say reducing sugar, guys, you already know, you already know, guys, that reducing sugar are those sugars which are having one free functional group. And that free functional group, it is not participating in the bonding. Not participating in bonding. And non-reducing disaccharides, right? You already know we have no free functional group. Means whatever functional group is there, it is participating in the bonding, no free functional groups. Now, when I say Benedict's test, it is given by reducing sugar. Now, when I say reducing sugar, guys, you have to remember, apart from the ones which are participating in the bonding, we have one like free functional group over here, right? It is to detect the presence of glucose in urine. Now, when I say glucose in urine, obviously, when the blood glucose levels will be high, guys, when the blood glucose levels will be high, remember what will happen? Yes, glucosuria, right? The glucose will come out via urine, right? So this condition, it is what is the importance, guys? It is helpful to diagnose this diabetes mellitus, right? Diabetes mellitus. Now, what this Benedict's reagent contains, guys, very, very important. It contains sodium carbonate, copper sulfate, and sodium citrate. Sodium carbonate, copper sulfate, and sodium citrate, right? So remember, guys, what is the composition? I mean, the reagent contains sodium carbonate, yes, the copper sulfate, and sodium citrate. Apart from that, remember, any sugar, I have already told you, with free aldehyde or keto group, right? The free aldehyde or keto group, right, will reduce the Benedict's reagent. That is what I just told, the reducing sugar. So it is not specific for glucose only. It can reduce like fructose also, because yeah, it is not actually fructose. Yeah. So that is something will reduce the Benedict's reagent. Now coming on to the next question, guys, that is the yeah the muta rotation, guys, the muta rotation. And let us just try to summarize this muta rotation. We have discussed it yesterday. So muta rotation, it is one of the properties of anomerism, anomerism, and that is nothing but this muta rotation. Muta rotation. Now, what does this mean, guys? It means that there is a change in the rotation of the plane polarized light, the plane polarized light, right? With time, with time, guys, right? With time. It is the change in the rotation of the plane polarized light with time, guys. Now, guys, we already know we have two glucose over here. You already know we have alpha glucose. These are like examples of anomerism, alpha glucose and beta glucose, right? So alpha glucose and beta glucose, these are examples of this anomerism. And you should know, if we say alpha glucose, whenever there is an interconversion, guys, you should remember, yes, so alpha glucose plus 112 degrees and beta glucose plus 19 degrees. This is because, guys, alpha to beta interconversion. So let us just try to see alpha glucose, yes, converting into beta glucose, and that is something which is no going in forward and backward direction. That is something you guys already know. That is the equilibrium point, guys, equilibrium point, and that is plus 52 degrees, right? So that is the, yeah, the property of anomerism, that is the muta rotation, guys, that you have to remember, right? Now, heteropolysaccharides and the two the two heteropolysaccharides that you have to remember, guys, over here. Now, heteropolysaccharides, guys, we have already discussed in detail as of now. Just I'm trying to summarize this question over here. Heteropolysaccharides. Heteropolysaccharides, guys, you already know it is made up of different type of no sugar units, right? So that is something, and one of the major heteropolysaccharides that we have already discussed, it is the glycosaminoglycans. It is also called as the heteroglycans, right? It is also called as mucopolysaccharides. So again, the very first question that we have discussed for today, it is again the same, right? So we have various heteropolysaccharides, right? So the major glycosaminoglycans, which you already know, guys, right? Yes, we have the chondrotin sulfate, right? We have keratin sulfate. So the question can be like in any ways. We have, yes, heparin sulfate, right? We have, yes, dermatin sulfate. We have heparin. Yes, we have already discussed this. And we have hyaluronic acid. Hyaluronic acid. Hyaluronic acid. So if we talk about the components of any two heteropolysaccharides, guys, right? We already know it's made up of repeating disaccharide units, the glycosaminoglycans. It's basically made up of this repeating disaccharide units, right? The disaccharide units. And we have already discussed this in detail, guys. We have the amino sugar and we have acidic sugar. We have acidic sugar, guys, right? Amino sugar, you already know we have, yes, the amino sugar, you already know we have glucosamine, or we can have galactosamine also. Galactosamine, right? And acidic sugar, you already know we have glucuronic acid, or we can have iduronic acid. So this glycosaminoglycans, which is no part of this heteropolysaccharides. It is having repeating disaccharides units composed of this amino sugar and acidic sugar. So even guys, you already know the 2-3 examples that we have like already discussed over here. Yes, the 2-3 examples that we have already like discussed over here. So remember, guys, this heparin. If I just ask about heparin, it is made. What is the composition of the heparin, guys? What is composition of heparin? You already know it is okay. Let me just change my pen. Yes, it is made up of, yes, it is made up of glucosamine plus iduronic acid. Iduronic acid, right? Even the hyaluronic acid, guys, it is made up of N-acetyl glucosamine plus glucuronic acid, right? Even heparin sulfate, guys, heparin sulfate, you already know it is made up of glucosamine plus glucuronic acid, right? So that is something you have to remember. Right. So that is any two you can just write according to your choice. Just mention this a short answer question over here. So we have discussed this heteropolysaccharides in detail, guys, right? So that was for today's class. We have discussed, yes, the mucopolysaccharides in detail, the definition, the composition, the properties, guys, right? We have discussed about, yeah, the heparin sulfate, which is present in the glomerular basement membrane, and the significance, what role does it have in our body, right? So apart from that, we have discussed the biochemical importance of heparin, right? And the keratin sulfate in detail, guys, right? Even we have discussed about the Benedict solution and the test is for diabetes and all, right? Even the muta rotation, guys, we have discussed is the property of the enomerism and heteropolysaccharides that we have already like discussed in the starting and yesterday also. So that was regarding today's session, guys. Yes, that was regarding today's session. Thank you for listening me out. And yes, so thank you. Thank you, guys.